Welcome to part 5 of this drag and drop tutorial for Angular. Today we are going to build a sortable list. As always, we are going for a strong and flexible implementation, so it should work for both horizontal and vertical lists. We will make use of the existing Draggable directive from part 1, together with the helper of part 4. I recommend to take a look at these videos as well. I will introduce a new sortable list directive, which will detect the actual sorting. The list itself will be rendered with a regular ng4 structural directive, and when you drag a sortable element and you exceed a certain threshold, the sortable list will emit a sort event. Now when the sort event is emitted, the user will be able to update the model, so that the actual sorting on the model is completely done outside of our directives. I will start with the existing project of part 4. Let's head to our app component.html and let's first collapse the existing code to have a better overview. And I add a new section for part 5, which is the sortable list. Now in this part I want to work with a list of boxes, so let's create one. Now that we have a list, let's add some styling. Now for this example I will make use of flexbox. Now that we have the list, let's make the boxes draggable by applying the Draggable directive from part 1. Now in order to make this list suitable for sorting, I will need to have a model, so let's create an array. Later we can just sort this array in our model and Angular will update the DOM for us. Now let's also add the draggable helper that we built in part 4. That is easily done with the draggable helper directive, which is a structural directive. And as you can see, we now have a draggable helper element. Now, the actual sorting will be done using a new directive which will be applied on the list. And let's call this directive sortable list. And it will look for any draggable element and detect the sorting for us. So let's create this directive and we can add it to our existing draggable module. So I open up a terminal and navigate to the Draggable directory, and I will have the Angular CLI generate a new directive called sortable list. And it is automatically added to the Draggable module, but we have to export it to use it outside the module. As you can see, my IDE already detected the activated directive. Now, inside the sortable list directive, we need to query for the draggable elements. Let's use the content children decorator for that, like we did in part 3. I call this list sortables, but the actual type that we query for is draggable directive. And this query here, draggable directive, matches the activated directive here in the app component. Now this list is getting populated by Angular automatically on the after content init lifecycle hook. So let's test this with a console log. And implement the interface as well, which is considered a good practice. Now, as you can see, I have 5 sortable items, so this works. As I just explained, this query list is populated by querying for draggable directives. But it would be good to be more specific so that we only query for the draggable elements that are sortable. We can achieve that by introducing a new sortable directive. So let's generate it. And have it exported as well. Now the sortable directive should just extend the draggable directive. Now we get a weird injection error, and that is because our draggable helper directive asks the injector for a draggable directive, but it can't find any. So our sortable directive was not recognized by the injector as an instance of draggable directive, which is a little bit weird, but we can fix this by explicitly providing our sortable directive. As you can see, it now works again. And as we reference our sortable directive in the decorator, it is a good practice to use forward ref to prevent weird issues. And now that we have the sortable directive, we can update the content children accordingly. And now we can also add specific styling for sortable elements. And we can achieve that by adding a sortable class from within our directive using a host binding. This means that every sortable directive will automatically have a sortable CSS class. Now, when a box is both sortable and being dragged, we can add specific styling to make it appear as a placeholder. Now that everything is in place, let's finally head to the sortable algorithm. First we will iterate over the sortable list, and for every sortable element, we will subscribe to the drag start event emitter. And then we need to measure the client rects, which are the client rectangles. And for the drag move, we have to detect the sorting. Now let's create the methods and let's test it with a console log. And as you can see, this seems to work fine. So let's continue with the implementation. Well, measuring the client rectangles is quite easy. We will add an array with client rect and we can use the get bounding client rect DOM method to get them from the sortable elements. And note that this element here is an element ref that was already exposed from inside the Draggable directive. So this is step 1. Now the sorting algorithm is quite complex. So let's first start with a very simple one. First I want to know the current index of the current sortable. So we need the current sortable. The query list needs to be converted to an array first, and then we use index of. Now let's test this with a console log. Now this works fine. Now I want to know the previous rectangle and the next rectangle to detect when the dragging passes their thresholds. Now, of course, they can be undefined when we are dragging the first or last element. Let's do the same for the next rectangle, which is undefined when we are dragging the last one. So now that we have the previous and next rectangles, we have to compare it with the pointer event coordinates. To get the current drag event, we can just ask it from the event emitter and pass it in our method. Now, if there is any previous rectangle, we have to check whether the pointer is above its vertical center. And if that is true, we have to move the element back. Now for the next rectangle, we will do the same, but now it needs to be below the vertical center. So let's test this simple implementation. As you can see, it works fine. Sorting is actually quite easy. Now we just have to inform the application that the actual model needs to be updated. And to do that, we will have to add an output event emitter, and let's call it sort. When we now have the console logs, we just have to emit an event. So what information should be included in a sort event? Well, basically just the current index and the new index. Now let's also add an interface for this event object, and I call it sort event. And now that we have an interface, we can associate this interface type with the event emitter to be more type safe. Now, inside our app component, we can listen for this sort event and call a method and pass the event object. So let's create a method. Now the event is a sort event. And to use the sort event interface, we have to export it first. Now updating the model is easily done by swapping the elements in the array. And as you can see, the sortable list finally works. Note that the helper element from part 4 works perfectly together with the DOM changes, as it is rendered inside an overlay with fixed positioning. This implementation, however, only works with vertical lists and only when the visual appearance is the same as the DOM order. If you are happy with this, you should be good. However, if you want to see a better implementation, keep watching. I will make things a little bit harder by having a vertical list and a horizontal list. So, and let's add styling as well. Now, as you can see, the horizontal list doesn't work. And also, when I change the styling of the vertical list to have a flex direction of column reverse, it won't work anymore as well. The reason is that we only look at the previous and next rectangle and that we assume them to have a certain position. So let's remove the current implementation completely. A better idea would be to sort all the rectangles by its distance to the current rectangle and then find the first rectangle that we need to swap with and then ignore the other rectangles. So first we have to get all the client rects, then sort them by the distance to the current sortable, and then find a rectangle that we need to swap with. And then we can just ignore the rest. So let's implement this. Now to sort an array, I first need to make a copy of the existing array to keep the original untouched. I use the slice method for that, which will return a copy. Now I can use the sort method, which requires a compare function. Now a compare function is a function that accepts two values and specifies how these values should be compared. Now in our case, we want to sort by the distance to the current rectangle. So let's get the current index and the current rectangle first. Like we did in our previous implementation. And now we can subtract the distances like this. Now of course we should also implement the distance function. Now as this is a pure function, I will define it outside of the class. Now, there are several ways to calculate the distance between two rectangles. For now, I will just simply calculate the distance between the upper left corners. Of course, it would be even better to use the center points. I use the Pythagorean equation to calculate the distance. A squared plus b squared equals c squared. So to know c, we have to take the square root of a squared plus b squared, where a and b are the horizontal and vertical distances. Now to test our sorting algorithm, we can do a console log of the sorted rectangles. So let's store it inside a variable. And log the left and top of the rectangles. Now let's add more boxes to the sortable list to demonstrate it even better. I will also need a flex wrap to wrap the horizontal list on a new row. Now when I start dragging box 1, as you can see, the rectangles are correctly sorted by the distance to box 1. Note that the rectangle of box 1 itself is included as well. We need to filter it out later. And now that we have correctly sorted the array, we can clean things up. So let's inline this sort function here. Let's remove the console log, remove the variable. Now we have to detect for each rectangle the sorting. Now if we need to sort, we have to skip the other rectangles. To do this, I will use the array sum method, which will skip the other array items when we return true. So let's first ignore the rectangle when it is the current rectangle. And now we have to check whether the rectangle is horizontally aligned compared to the current rectangle. Now I want to check whether it is before or after the current rectangle. Now when it is horizontal, I compare the left properties, and if vertical, I compare the top properties. Now using these two variables, I know the relative position of the rectangle. We now have to compare it to the pointer event. Let's have a move back and move forward variable, which should become true when the pointer event passes the threshold. Now when we are comparing horizontal, move back should only become true when the rectangle is actually positioned before and when the pointer exceeds the horizontal center, which is the left of the rectangle plus the width divided by 2. Now the same kind of logic is applied to move forward. And when not horizontal, when vertical, we should compare the client Y property and use the vertical center as threshold. Now let's first test with a console log. So this actually looks great. And now we can finally emit the sort event over here. Now we can get the rectangle's original index by using the index of method or of the original rectangle array, which was not affected by the sorting. And as you can see, it works now for both of the lists in every direction. So this was episode 4. I hope you enjoyed this video. Please subscribe to my channel to stay updated. And thanks for watching.